Welcome to StartupHakk. I'm Spencer Thomason, and today we're diving into one of the most important tools in modern programming, parallelism in C#. We're going to go through 4 different ways to run multi-threaded applications in .NET. So whether you're trying to speed up complex computation or just want to make your code more efficient, parallelism can help you run multiple tasks at the same time, giving your applications a serious performance boost. And in this video, we'll break down the different types of parallelism you can use in C#, and I'm going to walk you through some code examples to show you how exactly to implement in your own projects, because we love training software developers here at StartupHakk. So let's get started. All right, so let's go ahead and dive in today. Welcome to StartupHakk. I'm Spencer Thomason, and here at StartupHakk, we love to train software developers in our licensed coding bootcamp and build custom software solutions. I do a lot of work as a fractional CTO. With over a decade of executive leadership and a solid 25 years in software development, I've mastered the art of transforming technology, teams, and products. So we're going to dive into 4 different ways that you can run multi-threaded applications in .NET. So whether you're trying to really get your application to move faster, you just need code to execute in the background in parallel, this is the best way to do it. And we're going to dive through 4 of these today. We're going to start off by going through some slides today. So let's get switched over here to these slides. So we're going to go through some parallelism here in C#. So the definition and enhanced performance. Parallelism is the practice of executing multiple tasks simultaneously, which can significantly improve performance for CPU-bound and I/O-intensive operations in C#. The .NET framework facilitates this through system.threading.task namespaces. Now, there's different flexible techniques. Various parallelism techniques are available in C#, enabling developers to choose the most suitable methods based on their specific application requirements and use cases. Now, there's data parallelism, which involves distributed data across multiple processors and performing the same operation on each piece of data. And then there's task parallelism. Task parallelism involves executing different tasks concurrently, where each task may perform different operations. Now, there's also pipeline parallelisms, and pipeline parallelisms involves breaking a task into stages where each stage can run concurrently with others. Then there's asynchronous parallelism. Asynchronous parallelism allows for non-blocking operations, particularly useful for I/O-bound tasks like web requests or file operations. You see this a lot in web. Now, parallelism and multithreading are closely related concepts, but they're not exactly the same. So multithreading refers to the ability of a CPU or a program to execute multiple threads concurrently. A thread is the smallest unit of a process, and multithreading allows multiple tasks or part of a task to run independently. Parallelism builds on multithreading by running multiple threads or tasks at the same time, utilizing multiple CPU cores. It focuses on maximizing CPU usage to execute several computations simultaneously rather than sequentially. So, enough talk. Let's go ahead and dive into some code here. All right, now as always, make sure you go and pull down our code samples from GitHub here. So you can see we have the StartupHakk samples code repository. It has literally hundreds, and actually there's a link in this to a previous one. So between the two, I think we're up to almost 500 different code samples out there. So go pull these down, because we give all the code totally for free. Don't even ask for a sign-in. Free as in free, because we love training software developers here at StartupHakk. So this is where I'm getting this code from. So I pulled open this code, so you should have gone and downloaded that code. Hopefully you paused the video and went and got that code. And we're going to go through these 4 different types. So we can see that we have the async parallelism, the data parallelism, the task parallelism, and the pipeline parallelism. So these are the ones that we talked about from before. Now, each of these have been broken down to give you a really good sample on each of these. And so let's go ahead and dive into these and take a look at them. And we're going to open these here. So let's start with the async parallelism. So you can see here we have a series of URLs, right? And we want to go and fetch data off of each of these URLs in asynchronously, right? So first thing that we do is we set up just an array of the URLs. Once we have an array of the URLs, then we can walk through and create new tasks for each of the URLs, right? Now this task then goes through and fetches this data asynchronously, right? So it's going to be calling this async, and this async is the keyword here, and then uses the when all are done to come back and get these up. So let's go ahead and run that. We're just going to run up to that point here. So I'm going to actually comment these ones out here. And so let's comment those out, throw a breakpoint in here, and let's fire these guys up and just go to this one here. And again, I'm doing this real time so that you guys can see, because I think there's a lot of learning that happens, and we love to train software developers here. So I'd love to get into some of the learning for this. So we see that our window pops open here. I had a window that popped open over in the other one here, but I'm going to go ahead and step into this. Oops, I think I accidentally stepped over it. It ran it. Let's try that again. And like I said, I'm running this real time here for you guys because I try to be real here for you. All right, so F11 to step into it. All right, now we're in this window. I'm going to go ahead and close these bottom views here so that you guys can get a better view of what we're stepping through here on the code. Now, as I step into this here, you'll see that it creates the array. We create each of the new tasks. Now it's going to loop over these and fetch each one of them, right? And we can see these just going out and grabbing these different URLs. And then what I've got here is I've got an output window that says, hey, I fetched this many characters, I fetched this many characters, right? So it did all that. And it's hard to even debug sometimes with these when you're running parallel because it's actually executed all of them and come back. So you see that my output window was that it went and got each of these characters for each of these and then automatically finished out. So that's an example when you can see the win all, right? It'll do the task and it'll wait for all the tasks to complete before it finishes here. So this can go and fire off tasks for every single one, firing them asynchronously. And so this is an example of how to run those asynchronously. I'm just going to get that guy out of the way here. All right, so that's our async parallelism. Now let's dive into our data parallelism. So I'm going to uncomment this guy. Let's comment that guy out. And we're going to use data parallelism here, right? So let's run this one here. And a huge shout out to our amazing instructors who helped me come up with a lot of these samples. And so our instructors here at the courses are amazing. So you're going to see that we run through these. We create an array. It's going to fill the array with numbers, can perform a data parallel operation. I'm actually get this guy out of the way here so we can see. There we go. Now we can see a little better. Perform a data parallel operations using the parallel for. So this parallel for is a for loop that actually runs each of these different tasks in parallel, and actually it's creating those tasks behind the scenes here. So it's actually running each of these as we run through them. And sometimes debugging can be a little tricky. So I'm not going to run through all of that. We're going to run down to here. Then you notice that it will do the join on them, right? So what I've got here is it's going to run through this. So what it did is it ran through and did all of that computation and did those in parallel. So it was actually this for loop as it was looping over each of these different arrays. So over 100, this spun up 100 parallel threads that quickly, which is crazy fast, right? Like we see that the output here, and I'll show you this in real time, but well, you saw it in real time. It literally took just microseconds for that to run. So it's, so this is definitely efficient and a great way to quickly optimize your applications, right? So let's go ahead and close out this window here. Now we're going to go back to our next one, and let's see which one our next example is. So we're going to go to task parallelism. So for task parallelism, let's go ahead and add F11, step into that. What we're got here is it's going to actually create a task, and we're going to perform task 1, task 2, task 3. Now in this case, it's just going to give an artificial wait on each of these tasks, right? And that's all this is doing, is that it will wait for all the tasks to complete. Now this is going to perform the task and get the delay, right? And all of the delay is going to do is just wait and it's creating just, pretend there's some work going on right here, right? But then what it'll do, it'll run all of these, bring it to here where it completes all the tasks, but it's not reliant. None of these 3 tasks are blocking. And then you give it all 3 of the tasks. And so you can see that the wait all, you can give it actually an array of tasks here, right? And so, you can give it an array of tasks here. And so you can take a handful of different input methods here for this, but we can actually just give it as many tasks as we want, and it will execute all these tasks and then wait to this point before it gets to here. So all the tasks will execute. So it'll be kind of a little tricky, and so we're just going to run right to that. So it'll wait here. They all finish. Oops, sorry, I should have seen it over on the other. Let me see if I can run this. What we'll do is, let's run this one more time so I can show you the output here, because the output on this is pretty cool. So what I'm going to do is actually put it here to the first task. So let's run this guy again. And I'm going to drag my window over this time so you can see it here. So once we do that, so you can see it ran task 2, started 1, 3. So they actually ran out of different, and they completed in actually different orders because we had them set for different times, right? So each of these ran through and then waited finished it all at the same time. So very easy. .NET just makes this so easy, and that's what's so amazing. I remember writing multi-threaded applications, dealing with locking and resources, and it was so complicated, and now .NET just makes this so amazingly easy. And again, shout out to our awesome instructors on making these really great. And that's one of the things I love at StartupHakk is we have some amazing instructors, and I work through and approve all of our courses here. So let's see here. Let's make sure that we're not running anything in the background. All right, now our last one is the pipeline parallelism, okay? So let's run this guy to here. We're going to go down and let's step into this and we'll talk over it here. So we're going to create a new array, a new data. We're going to then read the tasks, right? So we're going to read all the data and create these tasks. We're then going to continue with, and you can see, so the first stage is the read the data. Second stage is the process the data. So this, the pipeline parallelism breaks down a task into multiple different stages. So then you can actually process these tasks in various stages and wait for each stage to finish. Now in this case, each of these stages, like the process data is just doing some looping, right, to give us some example of processing. And this writing data is just gonna, join those arrays. So, again, this is all just sample, but you can get the idea where it's breaking down these tasks in parallel so that each task where it has to read the data, then once it's done, it processes the data, but it's doing this in a non-blocking way, and that's the part that's really important. So I'm going to run this code to here, and we'll pull over our sample here again. So we can see as soon as I hit continue, it's going to continue to go through. Oops, I broke something. Okay, like I said, I do this real time, folks, so you can see it. But I broke something in the way that I was pausing it, and sometimes with multi-threading, you can get to that. So instead, let's put our breakpoint down here and see if it'll run all the way through to execute, because I think by having me stop it, it was actually breaking some of our parallelism. So we're going to hit F11 and step in there. I'm going to drag this over so we can see part of it. And boom, it did all of that, right? It did all of that in those orders. It read the data, processed the data, write the data. So this way it's still doing multi-threading, but allowing you to do it in such a way that it's non-blocking between those. So really cool, 4 simple explanations we've got right here in the code. So make sure you don't pull down all of these code samples, because here at StartupHakk, we love to train software developers in our custom coding, in our software coding boot camps, and to build custom software solutions for companies. So if your company has disconnected systems and needs help, or if you need some consulting around different ways to connect some of your systems, reach out. Hit up startuphakk.com/Spencer. If you're looking for the coding boot camps, go to startuphakk.com. We'll put the links for this code down below, so make sure you pull down those links, and we will catch you guys in our next video. Make sure you like and subscribe to the channel, because we bring you lots of great tutorials and tips that every developer should know. See you next time.